In this video, I will show you how you can define section properties for beam, column, walls and slabs, etc. So I will go in the define section properties, then click the frame sections. Here you can define the section properties for beams and columns. Here there is a lot of section available. For example, there is a steel sections, concrete beam, concrete column, steel beam, steel column, composite beam. So these are already predefined sections. So you can also define the channel section. For example, if channel section is not available, for example, I will import new properties. So for example, I want to import the steel channel section. I will click OK. Then which database, metric database or FPS, mean inch system or metric system. So whatsoever database user like, that can select. So here I am selecting metric system. Here I will select the material property of the, and you can also change for these channel sections. Here is all the channel sections. I will select all the channel section, or if I want less sections, I will select less. You can select up to your requirement. So I will click OK. Then all the sections will be available in the section database. So here is a C sections, W section already present. So now I will define a new section, for example for beam and column. Here I will create a beam section, add new. Here is a concrete, you can select from here, concrete section. So first of all I will define column of 300 by 300 millimeter. So here is the material property. You can select, for example, I want to select 28 megapascal, which is a 4000 psi, that is a 3000 psi. For columns I will select 28 megapascal. And notional size data and display color for the column. Nodes you can put according to your requirement. Section shape, there is multiple for example circular and rectangular for concrete. So right now I am using the column rectangular, 300 by 300, 300 by 300. And here is the reinforcement. I have to select what type of section, that is column or beam, reinforcement type, circular or reinforcement configuration is rectangular or circular. For example, for the circular column, that will be circular. So now I am designing the column. Longitudinal bars grade, that will be 60 grade, and for the confinement bars, that is also 60 grade, that is defined by me. And here is the option of reinforcement to be checked, reinforcement to be designed. Our 99% we check this option, reinforcement to be designed. It means that we want that software automatically calculate the reinforcement from the design loading. So after design loading, software will show reinforcement. That will definitely for the reinforcement we will discuss in the later videos. So you can select the properties. So here I have selected this option, there software will design the reinforcement automatically. What is in the first option, reinforcement to be checked? For that you have to provide the reinforcement. For example, you are making a trial. For example, first trial you have put 3 number of longitudinal bars in the 3 direction and 3 number of longitudinal bars in the 2 direction. What is 2 direction and 3 direction? In the face you can see here is a 2 direction, here is a 3 direction. I have selected 3 and also the confinement bars. Then after checking, when you check this option, software will check the reinforcement that provided by you. In the second option, software automatically calculate the reinforcement. Okay, here is the section is appearing. So here is the second option, that is the property modifiers. Property modifiers is a very important property for the simulation or modeling of reinforced concrete members. For example, here is a property modifiers for ACI beams should be 0.35 of IG, columns 0.7, walls uncracked, walls cracked, and flat slabs and flat plates and flat slabs, that is a 0.25 IG. That is also present in the ACI building code requirements for structural concrete and commentary ACI 318M14. So here you can also see basically what are these. When we do the numericals in our bachelor classes, we basically ignore the concrete below the neutral axis because concrete is weak, and we ignore the concrete on the tension side. We take on the compression side. So for that purpose of when we go in the simulation, we ignore the lower part and take the upper part. So that's why in the beams we take the 35% portion only, and for columns 70% and falls 70% or 35% according to the conditions. And for the flat slabs and flat plates, that is a 0.25 IG. So how we can put these values or use these values in our software? So here is the option. So for ignoring of concrete in the tension side, we put basically, I am defining the column, so I will put here 0.7. Okay, and section properties, cross section area, moment of inertia, moment of gyration, all things are calculated by the software automatically. Okay, so that is a column 300 by 300. Now I will create a copy of this column again. Add copy of this column 450 by 450 millimeter. I will again put here 450 by 450. Because I have created the copy, now there is already present the modifiers. Okay, reinforcement, rectangular column, 60 grade for longitudinal, 60 grade for confinement bars. Okay, now I will define the beam, for example 300 by 600 millimeter. So here is a depth 600 millimeter and width is 300 millimeter. When I will go in the reinforcement, I will select that is a beam, not the column. So here is a cover of rebar that is from the centroid to the outer concrete cover, that is a 60 millimeter, and longitudinal bar, that will be also confinement, and you can change according to your requirement. Okay, now let's see the property modifiers. We have to also change the property modifiers for the beam. So what are the property modifiers for the beam? That is a 0.35 IG. So I will put here 0.35. Okay, so that's how you can change the concrete properties, either it is a 24 megapascal or 28 megapascal, that depends according to your requirements. Okay, so here is a beam. Now I will show you how you can define the section properties for slabs. Here is a slab. I will create a new property, add new property, slab 150 millimeter, that is a 6-inch slab, and for slab I will select 24 megapascal and okay, and I will also change here the property modifiers here is a property modifiers. So what about the flat slab and flat plates? That is a 0.25 Ig. So here is a for flat plates. If you are modeling as a membrane, then put only F11, F22, F12, 0.25 Ig, and if you are modeling as a shell plate, so then model as a F11, all equal to 0.25. So I will just copy, Control C, and put here Control V. Here, okay. So a little bit difference, what is membrane and what is shell. The membrane, you can imagine a paper of any book, that the paper or have the properties that it have in plane bending behavior, can resist the in plane bending, but out of the plane bending cannot bearable. But in our slabs, that are shell elements that can resist both in plane moments and out of plane moments. These are the difference between the shell element and the plane element. So that's how you can define the slab elements. Okay, now I will define the wall sections. Here is a wall section, add new property. Here is I am defining wall of 200 millimeter, that is of 8 inch. Wall material, that will be 28 megapascal. Wall thickness, that will be 200 millimeter, and the modifiers for the wall are 1 I have to change also. So here I am considering the walls as uncracked, that because that are very heavy elements, I will put 0.70 Ig. Model as shell, and I will put everywhere. Because why I am putting everywhere, because I am considering the wall as a shell element. Okay, so that's how you can define beams, columns, slabs, and walls, etc. in ETABS. So if you change the unit system, for example, now it is appearing 8 meter to, for example, US default, all the units automatically convert into FPS system, but no dimension will change. For example, I want to see my section, prim section. Here is a beam 300 by 600 I want to see. So here you can see the dimensions that are not changed. 300 means 12 inch, that is a basically 1 inch is equal to 25.4 millimeter. Software automatically converted into inch. So 600 millimeter, that is at 2 feet 24 inch. So here, so software automatically convert the unit, nothing will change.